All right. So as you just finished copying this question down here, this is number 7, 3.5 in calculus, the Red Stewart calculus textbook. And we're talking about related rates here again. So this is a related rates question. So let's read and let's take a look here. A snowball, right away, snowball. A snowball. This is a three-dimensional object in the shape of a what? Sphere. Okay, we're talking about a sphere. Excellent. It's a sphere. A circle, two-dimensional, sphere, three-dimensional. Yeah, okay, sphere, okay. It melts. Ooh, the snowball is melting. Okay, you can picture that. It gets smaller as it melts, right? It gets smaller. So that its surface area decreases at a rate of 0.5 square centimeters per minute. All right. So let's keep reading, I guess. Find the rate at which the radius decreases when the radius is 4. So we have our 3 parts to this question, right? We have a given rate, we have an unknown rate, and we have a criteria there, right? We have a, what did I call it the other day? The constraint. Anyways, the time at which we're calculating these rates. All right. So let's write this down. Again, a snowball. So if you want to draw a snowball, I don't know if that helps, but a little snowball is how I draw my three-dimensional snowballs there. It's a sphere. Oh, am I still paused?
Yeah.
Oh. There you go. I didn't write down much. Okay, there you go. So I got a sphere here, and surface area. Okay, we talked about this yesterday, right? What is the what's the surface area of a sphere? You remember that formula? Right. Surface area for a sphere is 4 pi r squared. Okay, r squared. You remember that because it's area. 4 pi r squared. Okay, that's the formula for surface area. Now that relates the radius and the volume, and if the surface area, so the snowball melts, the surface area decreases. We could have been given a rate of decrease of the volume as well. We would just have to use a different formula. But we're given the surface area rate, so we want to use the surface area formula. Okay, so the surface area prime, I'll say, is 0.5 centimeters squared per minute. And find the rate of the radius. So r prime, we don't know. Okay, and yeah, so we have the conditional criteria is at r equals 4. All right. So related rates. 3 main things. Again, as you move on, there may be more rates involved, maybe 3 rates involved. So you might have 4 things. But we have given rate, unknown rate, and conditional criteria. Okay. So let's put this all together. I don't want to plug anything in yet, right? We got to take derivative first. So I'm going to take the derivative of both sides of this formula here. And so I've got SA prime equals, the only variable I have is the r. So I'm going to bring the 2 down, do power rule. So that's going to be 8 pi r to the 1. And then because we're taking this derivative with respect to time, right, we have to multiply by chain rule r prime there, chain rule. Okay? So this is so handy. We have our given, we have our given, and we have what we're trying to find here. So we just need to plug values in, rearrange some things, and we should be good to go. Okay? So I need to find r prime, so I'm going to go
staff, thanks for playing along.
over 8
if you get to section 3, you can continue to play the game, but when you get to section 3, we're going to hold that off.
Okay, so let's plug in some values then. So I've got, I'll change colors here. I've got surface area change. Now is this, it's decreasing, right? Ooh, decreasing. So actually we should make sure that this is a negative here. Negative, right? It's decreasing. In order for our, in order for the signs to match up with what we're actually trying to find, right? The radius is decreasing, so we are expecting a negative radius here, rate of change. So I've got 8 pi, and r is 4. So again, the rate of change of the radius is described by this right here, at 4 seconds. And if this was at 5 seconds, we just put a 5 in there. If it was at 7 seconds, we just put a 7 in there. And we would get a different rate of change of the radius. So again, that's the nice thing about math and about calculus. You can find an expression and just plug in different values if you want to find, you know, the value at a different time or a different radius. So we could plug in whatever value we want because we have the relationship, okay, established here. All right, so let's keep going with that. So on your calculator, what do you get there on your calculator? You should get negative 1 over 64 pi. R prime, negative 1 over 64 pi. Or what's that, roughly 0.005 centimeters per minute. Something like that. Okay. And so let's put our units on there and finish it off. So the radius, now I'm going to write it like this, changes at a rate of, and I'm going to make sure I put that negative in there, 1 over 64 pi. And the units are going to be centimeters per minute, right? Centimeters, the units length for length, and then time is in minutes in the question. Whoops. Circle that whole thing. Okay. Please make sure you identify your answer. Do a circle of some sort, please. All right. What do you guys think about that? Number 7. Pretty good? Okay. So a lot of these are going to be the same setup. Okay. You may have to change your conditional criteria here. You might have to change that. You might be given surface area here, add a surface area of, and you're going to have to change that to radius. You have to find out what the radius is, or whatever. So you'll have questions like that. Okay.